Okay, so we're going to be looking at solving quadratic equations algebraically. I'm actually going to do lesson 2.2 and then 2.1. I just habit of gotten into doing it first. The 2.1 is on graphing, basically solving equations graphically. And so I want to do these with doing them by hand first. Lots of times in the past I've not had calculators necessarily handed out yet, so easier to do these at home without it. So, all right, solving quadratic equations algebraically. So we're going to be looking at factoring, completing the square, quadratic formula today. Okay. So a reminder that when we're looking at a quadratic equation, it's in the form of ax squared plus bx plus c equals 0. So unless we are completing the square, we want it written in that form, right? So that it is equal to 0, so that we know the exact values of a, b, and c for the different techniques that we're going to use, right? Of factoring, or maybe just taking square roots of both sides, completing the square, or using the quadratic formula. So a reminder, when we're talking about factoring, we're using the zero product property. Right? So we're trying to find when they are equal to 0. So if I multiply one factor times the other, either one or the other one's got to be equal to 0. All right, so number one here, 2x squared plus 11x equals 6. All right, and this is the first one that you have on yours. All right, so we're going to go ahead and use factoring to solve this equation. And so let's go ahead and do, so the first thing we have to do is get everything on the same side. So we have 2x squared plus 11x minus 6 equals 0. And we've already worked on enough of these factoring so that you should be able to do it. So either use the airplane method or the box method, or some of you are probably able to do that in your head, right? Okay. So this one, when we factor this, right, we know that since to get 2x squared, we know that it's got to be 2x and x. Since our 6 is negative, then we're going to end up with two different numbers there, so, or a positive and negative. Right. So we're going to have, it's going to be positive 6 here and negative 1. So when we're finding the zeros, when we have just 1x, we know it's the opposite. When we have a coefficient of x, really that's pretty easy because you just have to add and divide. All right, so our zeros here are going to be, so we would add 1 divided by 2, so positive 1/2 or negative 6. So the factoring part, right, which you guys practice the factoring, so you should be good with that then. All right, then it's just a matter of solving. So one of the things that in the past, and when you were in the other classes, sometimes when it says to solve, sometimes people will just factor it, all right, and not find the zero. So make sure you remember that when it says to solve, that we are finding what does x equal, right? The actual value of x. Okay. All right, 6x squared plus 11x plus 4. You don't have this one, so go ahead and do that one. Solving x squared equals k. One of the things, a reminder, is that we're either going to get one solution in this case, or you could get two solutions, or there would be no real solution. So reminder, we cannot take the square root of a negative number, right? So those would give us non-real solutions there. And so you're going to want to say both things here, that there's no real solutions, and I would like to see the i's in the answers, all right, for when you have those. So we got 4x squared equals 8. Divide by 4. And take the square root of both sides. And don't forget what? Yep, plus or minus. plus or minus the square root of 2. Right. So make sure whenever you're taking the square root of both sides, you get a positive and a negative. Okay. Two different answers. All right, let's go ahead and do number 3. So the big thing, again, make sure that take the square root of both sides and reminder of the plus or minus. All right, so this one is 3 plus or minus the square root of 3. Yep, when you said solve, you're trying to get x by itself. Yep. So the thing is, I have this crossed out where it says plus or minus square root of 3 plus 3. All right, now, is it incorrect? No, it's not incorrect. It's just that when you write it this way, sometimes it looks like that plus 3 is under the radical. All right, so if we write it first, then we don't have that confusion is not there then. All right, good on that then? Okay. Completing the square. All right, so remember when we're talking about completing the square, we actually want to get something that looks like this problem we just did so that we can take the square root of both sides. That's the whole purpose for completing the square, is that either two things happen where we have a quadratic function and we're trying to find the vertex. That's one reason we would complete the square. The other reason is when we're solving equations and we want to get it so that we can just take the square root of both sides simply like we did in the second step here. Okay. So completing the square, remember we have x squared plus bx. So our third term, or our value of c, is going to be b over 2, so half of b squared. And you have to remember that we're going to add that to both sides when we're doing it. So we want the equation in the form of x squared plus bx equals c. We'll add half of b squared to both sides so that the left-hand side is a perfect square. And then take the square root of both sides and simplify. And it only works when the coefficient of x squared is 1. So if the coefficient of x squared is not 1, then you have to first get rid of that number before you can proceed. All right? All right, so here we've got x squared plus 6x minus 12 equals 0. All right, now this is an example I'm just going to do for you first. You can write it down if you want or just watch. First thing, it's got to be in the form x squared plus bx equals c. Okay. So then we're going to complete the square here. So when we complete the square, what goes in the parentheses here is always half of b. Okay. And then we're going to add b over 2 squared to both sides. So we've got to add 9 to both sides. Bless you. Right. So we x plus 3 quantity squared is equal to 21. So now we have it in that simple situation. All we have to do is take the square root of both sides. Now, one of the things that you should have in your memory bank, right, is the perfect square trinomials, which, so if I had x plus a, that quantity squared, then we've got x squared plus 2ax plus a squared, right? So the thing to remember is that whenever we're doing perfect square trinomials, which is basically what we're doing here, and we will come back to this over and over and over again. So if you know this, it really makes things a lot easier along the way as we're moving along. Okay. So we take the square root of both sides again. Get x plus 3 equals plus or minus the square root of 21. Right, and then subtract 3 from both sides. And always put that constant before the plus or minus. Makes things simpler in the long run. Right. So you've got this one, 8x squared minus 24x plus 3 equals 0. And we want to solve this by completing the square. So you can do one of two things first. Which one should I do first? Okay, so we'll move the 3. I'm always going to leave space there for when I am actually completing the square. All right. So what's our next step then? Divide by 8. Yep, we want just 1x squared, so we need to get rid of that coefficient of 8. Now, one of the things that we will do in this class is we will simplify radicals only when they're simple ones, okay? In this case here, we're going to end up with a radical that's really not very easy to work with, so we'll just leave it as it is then, all right, instead of simplifying it, okay? All right, so now you can go ahead and complete the square, and like I said, when you're done, just go ahead and leave the radical as it is. Don't try to simplify that radical then, all right? So go ahead and finish it. All right, so we get here, take square root of both sides. And x minus 3/2 equals plus or minus square root of 15/8. Right? And that's not a very easy radical to work with, so we're just going to leave it alone. So we'll say x equals 3/2 plus or minus square root of 15. Oops. Go ahead and leave it on the radical. Now, is that impossible to do? No, it's not impossible to do. It just takes a little bit of work. And we want to focus more on the math than we do want to focus on simplifying radicals in this class. All right? Okay. And you guys probably remember how to do the quadratic formula. Reminder that when we are using the quadratic formula, that we want it written in the form ax squared plus bx plus c equals 0. Now, when I use the quadratic formula, I like it pulled apart. So I'll pull the negative b over 2a out instead of leaving it under the radical. Now, what happens is you have two things that happen here. One, when it's in this form right here, people don't necessarily simplify it well. When it's in this form here, sometimes people make the mistake and think that the 2a is under the radical when it's not, okay, because you have the fraction bar there. So when I do quadratic formula, I actually prefer to do it this way for two reasons. One, because it gives me the axis of symmetry. All right? It tells me that when I'm graphing this, I know where I need to go. All right? That here's my axis of symmetry, cuts my graph in half, and my zeros are going to be, I'm going to go to the right, b squared over minus 4ac over 2a, and to the left from that spot. So you do it whichever way you prefer, right? Just as long as you simplify it correctly then. Okay? So we want it equal to 0. Identify your a, b, and c. You don't have to write them down, but sometimes it helps to do that. Just to identify them ahead of time, so when you start plugging them in, you plug them in correctly. I haven't got that far yet. All right. I put both negatives there. Okay. So this is, yep, x equals 10 over 2 plus or minus, and we got 100 plus 52, right? So 150, square root of 152 over 2. Right. So in this case, I do expect that you will simplify the square root of 152. all right, because that one can be done without too much difficulty. All right, so x equals 5 plus or minus, and square root of 152 simplifies to what, Scott? Michael? What times 13? No, square root of 152 is not 13. That's square root of 169 is 13. Right. So I think this is, isn't it 4 times 38? Yep. Okay. So this would be 2 times the square root of 38 over 2. So x equals 5 plus or minus the square root of 38. All right, remember we're looking for the largest square that goes into 152, and in this case it's 4. Remember that, Daniel? All right. Jason? All right. All right, so we got one left. Well, actually, there's 2 problems, 2 of them. Okay. The discriminant is the part underneath the radical from the quadratic formula, the b squared minus 4ac. If that number is positive, then we have 2 real solutions. If that number equals 0, then we have 1 solution. And if it is negative, then we have no real solutions. So if it's greater than 0, we have a situation that looks like here, right, where we would have 2 real solutions. If it equals 0, then we only have 1 because our vertex then is on the x-axis. And if it's negative, then it does not cross the x-axis and we have no real solutions. So it has to be in ax squared plus bx plus c equals 0 form to start. And then when I'm trying to find the number of type of solutions, all I use is the b squared minus 4ac. So we set it equal to 0. And then all we're going to calculate is the discriminant to tell how many and what types of solutions we have then. So since we get negative 31, then we say there are no real solutions. Now you could say that there are 2 complex solutions, right? Or 2 non-real complex solutions, but you can just say no real solutions in this case. But if we were actually solving this, then we would end up with, we'd have I in our answer, so we would have 2 complex. Okay. All right. Factoring without when we have our powers are greater than 2. Right? So here we have 4x to the 4th minus 13x squared plus 3 equals 0. And we want to solve this equation by factoring. So this is the same as for the most part. All right. So the thing to remember is that if I have, let's do this to factor, right? So we know that's x plus 2 and x plus 4. Right? The only difference is if I change these powers, the power of the first term has to be twice or double the power of the middle term for me to be able to factor. So I can factor x squared plus 6x plus 8 equals 0, the same as I would factor x to the fourth plus 6x squared plus 8. Just the only difference is that now I'm going to use x squared instead of x. Right? And if it was 6 and 3, then we would have x cubed would be our first term. All right? And whenever you're doing those, you need to make sure that you pay attention to the if I can factor it again or not. So this example here, 4x to the fourth minus 13x squared plus 3. When I factor that, I'm going to have 4x squared minus 1 and x squared minus 3 equals 0. So the difference is that now I'm going to end up with 4 solutions instead of 2. So the big thing is just remembering that, right? So x here equals plus or minus 1/2, and here is going to be plus or minus the square root of 3. And quite often you're going to end up with a radical in your answers for those. So the factoring is done the same. The only difference is that you're going to have squared here instead of just x. Right? You okay with that?
So just took the square root of both, unless I got...
Add 1, divide by 4, take square root. Okay. Yeah, I did it in my head instead of writing it down. All right? So you go ahead and do this one here, number 7.